Well, this is an example of a static local class, and by static I mean implicitly static. And what we've got here is same as before, basically top level class there, and inside this method 2 we have this local class declared, and this time the class is going to be static, and it's static because the method it's declared in method 2 here is a static method, so that makes the class static. And as a result of that, of course, it doesn't get an instance of the enclosing class passed to it, so into its constructor that is. So it has no automatic right to access instance variables in here. So let's see what we've got here. Well, first of all, that obviously is going to be a compiler error. For the same reason as before, you're not allowed to have static stuff inside a local class like that, and the same down here as well. Right, what have we got here? Well, L and N for a start will both generate errors. L because again it's local but not final, and same with N, that's a local variable but it's not final, so you can't access it. And method 3 here, that will give an error too if you try and access that, because it's an instance method, and it's an instance method in the enclosing class, so you haven't got access to that automatically either. What have we got here? Right, method 1, yes, we can certainly get it method 1 because it is static. Even though it's private, it's static, so of course being private it means we'll have to have an access method put in there, but you can access it anyway. And J and K, what are they? Right, K is final, so that's no problem, and J is public, private, static. It's a static field, so we've got access to it. And what about AI and AJ? Well, yes, we can both access those because those are in the superclass. And of course, this class can access anything that's in the superclass, just like any ordinary class. There's no restriction on that. Behaves exactly as you would expect. And M, where's M? Oh, right, yes. M is final, so we've got access to that. Okay. So basically, you can only get it final local variables and static methods and fields in the enclosing class, or class S, I should say. Normal rules, of course. Okay, well, when the compiler compiles classes which are local classes, it has to invent names for them because it flattens them out as usual, as you might expect. And this example here shows just about every combination I can come up with. So I can't think of anything that's missing here, but here we go. So obviously we got this class here, and this is a member class, so obviously just $B there and $C. Now this here is a local class D, and what it does is it puts a number in front of the D, like that. So it goes $1D. And the reason for that is because you may have that class name may be used more than once. So if it's used again, these are different classes naturally, if it's used again, well then you use 2D. Okay, and we got C here, and as that's a local class, at that level we use 1C. And here is the constructor there, and is D used again in there. So this time we're up to 3. 1, 2, 3. It just increases basically. And here's this method inside this class QQQ. And so this one's going to be 2C. It's 2C because we've got a C already up there. And then in here, inside C is a method O, and in that is a couple of classes G and H. So obviously it goes QQQ $2C $1G for that, and then you got that embedded inside of that, so it goes $1G $H, because that is now a member class in there. Right, obviously we can get, this is obviously $1E, it's the first time E's been mentioned at this level, and this here is $1E, $1C. You'll notice that's 1C and not something like 3C or anything like that, because the bit in front of that is enough to make it unique. So it's unique at that level, obviously. This is $1F, as you might expect, and this is last bit down here is $4D. So we've had 3 up there, so we're up to 4 now. Now, having said all that, of course the numbers uniquely identify the local class in case the same name is used more than once. Now, the actual number that's used is not given in the specification at all, not specified by the language spec, but the Java compiler, what it does is it just goes by the lexical order in which they occur in the class. So it's simple. You can only refer to a local class within the method, constructor, or block which declares it. And in fact, the scope may be smaller than that, because it runs from the point of declaration to the end of the enclosing block. This, of course, it includes the class itself, and you can't redeclare a local class as a local class within the same method, block, or constructor. So you can't have 2 local classes with the same name inside a method, block, or constructor. Now, for switch statements, it's a little bit different. Any local class declared inside a switch statement, its scope is from the declaration to the next switch label, or to the end of the switch statement if that comes first. So here's an example to illustrate that. Is this a global class here? We've got a member class there declared as C, and we've got this method here, and inside here we go new C. Okay. Now what that will do is create a global.c, which is that one there, and here we've got a class C which extends global.c, so it can do that because that's unique. If it had just said extends C, of course that would be an error, because it would effectively be a circular definition, because the scope of that starts from there to the end of the block effectively, so for the rest of this method in effect. So you can't say just C there, it has to be global.c to pick up that one. And if we do new C now, it's going to create global $1C. That's effectively what it's going to be creating an instance of. Right, here's this switch statement with class Z defined there, and it of course is going to be global $1Z. And if we up here we had new Z, that would be an error because Z had not been declared yet. And down here, if we do new Z, again we get an error because because global $1Z is not in scope. It goes out of scope when it comes to that label. And here we've got things the right way around. We've got a class Z declared, so that's going to be global $2Z. And we can do new Z there, and that's fine because that creates that one. Okay.